We are learning about what is an inverse. What does it mean to invert something? Flip it. Flip it. So that's what we're doing today with X and Y. We're going to flip them. So the instructions for problems 1, 2, and 3, it says find the inverse of each relation. Determine if the inverse is a function. So number 1, we have f. Our relation is given in that table. We need to find the inverse. So to represent an inverse, we use the -1 power. So f to the -1 power means f inverse. And f inverse is also going to be a table. And to find the inverse, all we're going to do is switch the x and the y. So for my first ordered pair, I have 1, 1. Well, if I switch it, what would it be? It's still going to be 1, 1. So that's not a good example. Same thing with the next point. If it's 2, 2, if I flip the order, what is it? It's still 2, 2. So still not a good example. But the next one is a good example because the next point is 3, 4. So if I flip 3, 4, what would that be? 4, 3. All we're doing, we're switching the x and the y. That's what we're doing, is switching x and y. That's what we're doing today. And for that last one, 4, 8, when I switch it, what would it be? 8, 4. So that was the first part. We are just finding the inverse. So to find the inverse, you switch the x and y. Then the second part of the instructions, we need to determine if the inverse is a function. Now remember back to Algebra 1. In order for a relation to be a function, that means your x values do not repeat. So in order for the relation to be a function, that means the x values do not repeat. So when you're looking at your inverse, all we care about are the x's. So this is all we need to look at. Just look at the x column only. And looking at those x values, we have a 1, a 2, a 4, and 8. Did any of those numbers repeat themselves? No. So that means this one is a function. So f inverse is a function. This is an Algebra 1 review as far as it being a function. So f inverse is a function because its x values do not repeat. So if the x values do repeat, it's not a function. If they do repeat, it's not a function. We'll see some more examples. Let's look at number 2. The first thing we need to do is find the inverse. So we're given g, and this time they made the table horizontal, but it's still going to be the same process. To write the inverse, we write g to the -1 power. So g to the -1 power stands for g inverse. And we're going to take those values in that table, and we're going to flip them. So 3, -1, when I switch it, becomes what? -1, 3. And 4, -2, when I switch it, it becomes -2, 4. And 1, -4, when I switch it, it becomes -4, 1. And for that last one, -1, -4, when I switch it, it becomes -4, -1. So there's g inverse. Now we also have to decide, is g inverse a function? So to determine whether or not it's a function, we need to look at the x values. So for the x values, we have a -1, a -2, a -4, a -4. Did the x values repeat? Yes. What repeated? The -4s repeat. So if x repeats, it is not a function. So we need to say that g inverse is not a function. That means the same. For part 1. Okay, I want you to do 3 and 4. Write the inverse table values and determine is the inverse a function. So I want you to do 3 and 4. Okay, problem 3. The first thing we need to do is find the inverse table values. So H inverse what would be the first ordered pair? 2, 0, what's next? 4, 1, what's next? 5, 2, and what's the last one? 6, 4. So there's the inverse table. Now check the x values. We have 2, 4, 5, 6. Did any of those repeat? No. So is it a function? Yes. So we need to say f inverse is a function. Oh, sorry. Instead of f, this needs to be h. So if you put h, you're right. If you put f, you're wrong. So I was wrong. So h inverse is a function. Then number 4, we have k. Now we need to write the table values for k inverse. What would be the first ordered pair? 0, 1. What about the next one? 1, 3. Next one, 2, 4. And the last one, 0, 5. Now looking at the x's, did any of those repeat? 0 repeated. So if an x value repeats, is it a function? No. So we need to state that k inverse is not a function. Okay, so that's part 1. Part 2. Part 2, next set of instructions say to graph the inverse of each function, determine if the inverse is a function. So we're going to do the same thing at first. I'm going to make a table of values. So I'm going to write down the ordered pair for each point on that graph for f of x. And let me put them in black as I go. This point right here, what is this ordered pair? -4, 6. The next point, what is the next point? -2, 5. What is the next point? 0, 4. What is the next point? 2, 3. And what is that last point? 4, 2. So those are the points for f of x. Now, if I'm writing down the points for the inverse, now what we need to do is switch those ordered pairs. So what would be the first point for f inverse? 6, -4. What would be the next point for f inverse? 5, -2. What would be the next point? 4, 0. Next point, 3, 2, and 2, 4. So now we need to plot those points for f inverse. So the first point we need to plot is 6, -4. So 6 drops down to -4. Then 5, -2. So 5, drop it down to -2. 4, 0, will be on the x-axis. 3, 2, so 3 goes up to 2. And 2, 4. 2 goes up to 4. And once you have those points, go ahead and connect them. And we need to label this. This is F inverse of x. F inverse of x. Now, something that is extra, but I do want to point out to you, is that when you graph a function and its inverse, the inverse is just a reflection over the linear equation y equals x. So let me show you where y equals x goes. So y equals x goes to the bottom left corner, the origin, and the top right corner. And actually, I want to do a dashed line. So if you look at that green line, can you tell that the blue and red are a reflection over that line? And more specifically, let me just kind of highlight some things for you. Notice this little piece right here. Did it reflect over that line? It's here and here. Yeah. And this part right here, did it reflect over that green line? Yes, it sure did. So notice it's a reflection over that line. So if you kind of think about where that line should be placed, then you can kind of tell whether or not your points were put in the correct place. Now, one more thing that we have not finished is the second part. It says determine if the inverse is a function. Now, remember something called the vertical line test? Vertical line test. So here is a graph, and here is a graph. Now the vertical line test states that if you draw a vertical line through your graph, if it touches only one time, then yes, it's a function. So if I draw a vertical line, let me change to blue. If I draw a vertical line, how many times did it touch? It touches only one time. So this one is a function because when I draw a vertical line, it passes through my graph only one time. But on my circle, if I draw a vertical line through my circle, how many times does it touch? Twice. So if it touches more than once, it is not a function. So there's a brief review about the vertical line test. So if you draw a vertical line and it touches only one time, yes, it's a function. But if you draw a vertical line and it touches more than one time, it's not a function. So let's look back at number 5. So just look at this part in red. If I draw a vertical line, how many times would it touch just the red part? One time. So that means F inverse is a function. So if you draw a vertical line, it touches F inverse only one time. So F inverse is a function. Okay, next one, number 6. Okay, again, I'm going to write down the points for g of x. I'll do it point by point, starting with the left point. So starting with the left point, what's the x value for that point? -1, and the y value is 1.5, 1.5. The next point, what is the x value? 0, and the y value is 2. What is the next point? 1, 3. What is the next point? 2, 5. Now I'm going to go ahead and write over here the points for g inverse. So if we flip those points, what would be the first point? 1.5, -1. What would be the next point? 2, 0. What would be the next point? 3, 1. And the next point? 5, 2. So plot the point for g inverse. So 1.5, go halfway between 1 and 2, and go down to -1. 2, 0 will be on the x-axis. 3, 1 is in quadrant 1. 5, 2 is also in quadrant 1. And then connect those points. Now I'm going to go ahead and draw in that line of symmetry. Remember, when you draw the inverse, it should reflect over the line y equals x. So it goes from the bottom left corner through the origin through the top right corner. Does it look like the blue curve reflected over that line? Yes, it does. Now this one you can see it better because all of the graph is above that line. And now we have to decide, is g inverse a function? If I draw a vertical line, how many times does it touch the red curve? Only one time. So is g inverse a function? Yes, so g inverse is a function. Okay, I want you to do number 7. Okay, for h of x, what is this first point? 0, negative 4. What is the next point? 1, negative 3. And what is the last point at the top? Oh, sorry, there's the third one. What's the third one? 2, 0. And the one at the top would be 3, 5. Now flip those points. What would be the first one? Negative 4, 0. What would be the next one? Negative 3, 1. Next point. 0, 2. And the last one. 5, 3. Now plot those points. So negative 4, 0 would be over here on the x-axis. Negative 3, 1 would be up here. 0, 2 would be right here. And 5, 3. And connect those points. And is h inverse a function? Yeah, if I draw a vertical line, it touches only one time. So h inverse is a function. So h inverse is a function. Okay, next section. Now we're still doing the same thing, except now they're giving us an equation. So now we have to come up with f of x and graph the original function. So for number 8, we're given h of x equals x minus 4, and outside the parentheses it's squared. So because of that square, what type of graph would this be? What would it look like? A parabola. It's going to be that U shape. And what does the -4 do to the parabola? Moves it to the right 4 units. So from the origin, move it to the right 4 units. And for a parabola, if you go over 1, what is 1 squared? So over 1, up 1. If I go over 2, what is 2 squared? 4. So over 2, up 4. Over 2, up 4. If I go over 3, what is 3 squared? 9. Do I have enough room to go up 9? No. So it's just these points. Then I need you to label it after you connect your points. I need you to label this as h of x. So this is h of x. Now, to come up with the inverse, first I'm going to make a table of values. And this time I'm only going to do a table for the original function. So what is that first point? Right here. 2, 4. What is the next point right here? 3, 1. What's the next point? 4, 0. What's the next point? 5, 1. What's that last point? 6, 4. Now, I'm not going to write the inverse table. I'm just going to look at those points, flip it mentally, and then plot that point. So do a mental flip. So here, 2, 4. When I flip it, what would it be? 4, 2. So plot a point at 4, 2. 3, 1. When I flip it, what would the point be? 1, 3. 4, 0. When I flip that point, what would it be? 0, 4. 4, 0. When you flip it, it's 0, 4. The next point, 5, 1. When we flip it, what would it be? 1, 5. Next point, 6, 4. When we flip it, it would be 4, 6. Then connect your points. Make sure you label this one. This one is h inverse of x. So notice the original graph is the parabola. What do you notice about the inverse? It still looks like a parabola, but what happened to the parabola? It turned. It rotated clockwise, 90 degrees. Now, did they ask you if it's a function for the inverse? No, but looking at h inverse, would it be a function? No, why not? Yeah, if you draw a vertical line, it touches the red twice, so it's not a function. But they didn't ask for that, that's just extra. Next one, number 9. What is number 9 going to look like? It's going to look like that. What does the plus 2 at the back make it do? Up 2. So from the origin, move up 2. Then use your perfect squares. If I go over 1, what's the square root of 1? So over 1, up 1. After 1, what's the next perfect square? If I go over 4, what's the square root of 4? 2. So over 4, up 2. After 4, what's the next perfect square? 9. Do I have enough room to go over 9? No, so it's just 3 points this time. And I'm going to go ahead and write down, well, first of all, let's label this is g of x. And let's write down the table of values for g of x. What is the first point for g of x? What's the x value? 0, and the y value is 2, so it's going to be 0, 2. What's the next point? 1, 1, 3. And what's the last point? 4, 4. Now again, we are going to flip these points mentally. So 0, 2, when I flip it, what would it be? 2, 0. 1, 3, when I flip it, it would be 3, 1. 4, 4, when I flip it, it would be, so that would be a shared point. Now notice the original curve to the right. How is this one going to curve? It's going to curve upward. And we need to label this one. This is G inverse of X. And number 10. Looking at that equation, what is that graph going to look like? A parabola. What does the plus 1 make it do? Left 1. What does the minus 4 make it do? Down 4. So from the origin, we need to move left 1, down 4. If I go over 1, what is 1 squared? 1. So over 1, up 1. Over 1, up 1. If I go over 2, what is 2 squared? So over 2, up 4. Over 2, up 4. If I go over 3, what's 3 squared? 9. So over 3, up 9. Over 3, up 9. And connect those points. And label this one, this is M of X. And out to the side, I'm going to list the points for M of X. And what's the first point? Negative 4, 5. What's the next point? Negative 3, 0. What's the next point? Negative 2, negative 3. What's the next point? Negative 1, negative 4. What's the next point? 0, negative 3. What's the next point? 1, 0, and that last point. 2, 5. Now we are going to find these inverse points mentally from that table. So negative 4, 5. What would be the first point? 5, negative 4. Negative 3, 0. What would that point be? 0, negative 3. So that would be a shared point. Negative 2, negative 3. When we flip it, what would it be? Negative 3, negative 2. Negative 1, negative 4. When we flip it, it would be negative 4, negative 1. 0, negative 3. Negative 3, 0. So another shared point. 1, 0 becomes 0, 1. And 2, 5 becomes 5, 2. Connect those points. And we need to label this one. This is M inverse of X. So M inverse points to the side, M of X points upward. Okay, on the back, we have 3 more that we have to graph. Now we're taking it a little bit farther back, and this time f of x equals 3x plus 6. Notice that is slope-intercept form. Remember y equals mx plus b? What does m stand for? Slope. What does b stand for? The y-intercept. So the first thing we'll have to do is graph the original line. Then we'll have to take those points and flip them to find the inverse. So looking at number 10, what is that y-intercept? 6. So we need to start on the y-axis at 6. So put your point on the 6. Now slope is rise over run, so I need to make this to a fraction. So this would be 3 over 1. So rise over run, we need to rise 3, run 1. So if the rise is positive, do we go up or down? Up. So I need to go up 3, right 1. Do I have enough room to do that? So what's the opposite of up 3, right 1? Down 3, left 1, down 3, left 1, down 3, left 1. Then connect those points. And now, so it says graph each function. So we did that. What does it say after graph each function? Solve algebraically. What does algebraically mean? Yeah, that means use some algebra. So use some algebra to find the inverse. So here's what we need to do is we need to first write down the equation we're given. We were given f of x equals 3x plus 6. So that's the equation they gave us. What does f of x mean? So this is y equals 3x plus 6. Now here's how you find an inverse. To find the inverse, you switch x and y. So what I mean by that, if you see a y, you switch it to an x. If you see an x, you switch it to a y. So the y, switch it to an x, and the x, switch it to a y. Now solve for y. So if I want this y by itself, I need to get rid of this 6. So what happens to 6 when I move it to the other side? It becomes negative 6. So 6, move it to the other side, becomes negative 6. How do I get rid of that 3? Divide all 3 of these by 3. What number's in front of this x? A 1. So what fraction should I put in front of x? 1/3, so 1/3 x. What's negative 6 divided by 3? Negative 2. The 3's cancel. And here's my equation for the inverse. Y equals 1/3 x minus 2. And I'll go ahead and make this y inverse, so I remember that is the inverse equation. So looking at the inverse equation, what's the y-intercept? Negative 2. Slope is rise over run. So we need to rise 1, run 3. So if the rise is positive, do we go up or down? Up. So up 1, right 3, up 1, right 3. And the opposite would be down 1, left 3, shared point, down 1, left 3. Then connect those points. And I probably should have done some labeling. The red one is f inverse. And the blue one is that original one, f of x. Yes, you need to label. You need to label. So there's f of x, there's f inverse. Okay, next one, number 12. First thing we need to do is graph that line. So what is the y-intercept? Negative 6. The slope is 2 over 1. So if the rise is positive, do we go up or down? Up. So we need to go up to right 1, up to right 1, up to right 1. And what's the opposite of up to right 1? Down to left 1. And I need to label this one is g of x. Now to find the inverse, use the equation they gave us. So they gave us g of x equals 2x minus 6. What does g of x mean? Y. So this would be y equals 2x minus 6. How do you find the inverse? you have to switch the x and y. So the y switches to an x, and the x switches to a y. Now get the y by itself. So what happens to the negative 6 when I move it to the other side? So this will be x plus 6 equals 2y. Divide all three of these by 2. And what number's in front of the x? A 1. So what fraction should be in front of x? So this would be 1/2 x. And what's 6 divided by 2? 3. And here the 2's cancel. And that equals y. And actually this should be y inverse. So what's the y-intercept? 3. If the slope is 1/2, which way do I go? Up 1, right 2, up 1, right 2. And the opposite would be down 1, left 2, down 1, left 2, down 1, left 2. Then connect these points and make sure you label this one as G inverse. Okay, I want you to do problem 13. Graph the line, find the inverse algebraically, and graph the inverse. Number 13, what's the y-intercept? -5. Slope needs to be fraction, so this needs to be 5/1. So I need to rise 5, run 1, rise 5, run 1. So if the rise is positive, make sure you're going up. And we need to label this one. This one is h of x, so make sure you labeled yours. So h of x. Now, we have to solve algebraically for the inverse. So the equation we're given is h of x equals 5x minus 5. And what does h of x mean? So this would be y equals 5x minus 5. And how do you find the inverse? Change the x and y. So the y changes to an x, and the x changes to a y. What's next? Move the -5. What happens to -5 when I move it to the other side? Changes +5 equals 5y. Divide everything by 5. Yes, there's a 1 in front, so this would be 1/5 x plus 1 equals y. and I'll make that y inverse. So what's the y-intercept? 1. If my slope is 1/5, which way do I go? Up 1, right 5, down 1, left 5. And make sure you label this one. This one is H inverse. Okay, the last two. Multiple choice. So for problem 14, it says, given the graph of f of x, which of the following point is on the inverse of f of x? Well, let's start with the first point. What is this ordered pair? -6, -2. So what would the inverse point be? -2, -6. Is that an answer choice? Yes, it is. Correct answer is C. If you invert that point, -6, -2, that inverse point would be -2, -6. So C is correct. Then the last one, number 15. Given f inverse of x is equal to -2x plus 6, which of the following is f of x? So now they're giving us the inverse equation. We have to come up with the original equation. Let's see, they gave us, I'm going to write this as f of x equals -2x plus 6. What does f of x mean? Y, or f inverse of x just means y, equals -2x plus 6. So that's the inverse equation. But what happened to get that inverse equation? They switched the x and y. So if I want the original equation, what will I have to do? Change it back. So the y changes to x, and the x changes to y. What do we do next? Move the 6 to the other side, and what happens to that 6? Becomes -6 equals -2y. Make sure you bring down the negative with the 2y. And how do I get the y by itself? Divide everything by -2. What number's in front of the x? A 1. So this would be -1/2 x. And -6 divided by -2 becomes +3 equals y. So -1/2 x plus 3. Which answer choice is that? D.